Welcome to Elixir Mix, your weekly Elixir podcast, talking with members of the community. My name is Mark Erickson, and on our panel today, we have Michael Reese.
Hello, Elixir friends.
Josh Adams.
Hey there.
And today we are joined by two special guests, Eric and Andrea. Could you both introduce yourselves?
Hi. Yeah. So I am Eric. I'm an Elixir core team member, and I'm happy to be on the podcast.
Very similar here. My name is Andrea. I am a member of the Elixir team as well, and this is exciting.
This episode is sponsored by Sentry.io. Recently, I came across a great tool for tracking and monitoring problems in my apps. Then I asked them if they wanted to sponsor the show and allow me to share my experience with you. Sentry provides a terrific interface for keeping track of what's going on with my app. It also tracks releases so I can tell if what I deployed makes things better or worse. They give full stack traces and as much information as possible about the situation when the error occurred to help you track down the errors. Plus, one thing I love, you can customize the context provided by Sentry. So, if you're looking for specific information about the request, you can provide it. It automatically scrubs passwords and secure information, and you can customize the scrubbing as well. Finally, it has a user feedback system built in that you can use to get information from your users. Oh, and I also love that they support open source to the point where they actually open sourced Sentry if you want to self-host it. Use the code DevChat at Sentry.io to get 2 months free on Sentry's small plan. That's code DevChat at Sentry.io.
Awesome. So we wanted to invite you guys on because you've both been part of a coordinated effort to work on the Mint library. And we want to talk about what that is and why people should be interested in it and learn about this. But one of the questions I have, since we have two Elixir core team members on, I was just curious, are you guys doing Elixir core team or core development full-time, part-time? Are you sponsored in any way? What is that like?
So I do Elixir development full-time now on the core language. I am sponsored by a company called Breaks, and I just started there, so we're looking into doing a few refactorings with the compiler to start out with, and eventually go on to doing some kind of software. We're looking into different kinds of doing software verification.
Nice.
That's super exciting.
So, for me, I do not do Elixir full-time. Right now I work at a company called community.com, and they let me work on open source stuff when there's stuff that's needed by the company, or so I get some open source time, but I do Elixir itself in my free time. But for myself, most of the work that I do really in Elixir is about the community. So it's mostly libraries, I would say. I maintain a bunch of libraries that are pretty widely used. So most of my work goes in those right now. Since there's not a lot of work to do in Elixir, that's kind of doable in free time, I think. So
great. Well, I appreciate that both of you have some corporate kind of backing to put time into this project and the community. So I think it's great. So I'd love for you guys to kind of give us an introduction to Mint, this library you worked on. I'm curious about how you got working on it together, and just kind of give us an overview of what Mint is and why people should know about this.
Yeah, sure. So Mint is a low-level HTTP library. It's a library for clients, and the main distinctive feature of Mint is that it's processless, which means that it doesn't spawn any separate processes. Instead, it's up to you as the user of the library to kind of manage the processes yourself if you need to. So this gives the user a lot of flexibility into designing their own process architecture that fits their application or their use case.
So one question I had along these lines was around HTTPC. So this is a little bit fuzzy memory for me. A long time ago, I was helping to contribute to a library that when it booted up, like once every 24 hours, it would download a file, and it just wanted to like download this one file. I think it was a time zone database or something. And so they had pulled in Hackney, and there was an entire pool of clients sitting there just to download one file every 24 hours. And they had pulled it in because they needed full TLS verification of the certificates. And so from my understanding is I think Mint does full TLS certificate checking. Sorry. And also, do you think that Mint has mostly at this point replaced the use case of the HTTPC, that standard library? Would you mostly use Mint in those use cases now, or are those still different use cases?
Yeah, so I think that's a good question. So for me, since I worked on Mint myself, I would usually reach for Mint, I would say. But I would also say that HTTPC and Mint have kind of different use cases. So Mint is a much more low-level library than HTTPC. HTTPC, for example, it has a much simpler and easier interface, I would say, or at least simpler interface. For example, you don't have to worry about spawning connections. You don't have to worry about creating new connections. You also, it also kind of handles the concurrency for you, because it can do things like spawn a maximum number of connections per host that you are connecting to. So it's more general purpose and more suited for doing things like you suggested, like doing simple requests where you don't need, where you might not need, where you don't have any particular performance requirements. But I just want to point out another thing that you were talking about, is that HTTPC does do certificate verification if you provide the certificates for it. So it doesn't have a built-in certificate store. So, for example, when you use your when you go to a website with your browser, the browser has some certificates that are called the certificate authorities, and HTTPC doesn't provide that for you. So if you want signing, you need to either have the certificate for the website that you are connected to, or you need to use a certificate store. And this Mint provides for you, because we think that by default we should always do the most secure thing. And if you want to deviate from that, that should be an opt-out. So like the safe way should be the default. So I would say that those are the main differences.
So what certificates
libraries?
What certificates go in the store? Is it like the Mozilla default store or something, or do you handpick?
Yes.
Okay.
Yeah, so that's what we use. So we use the Mozilla default store, which is used by a bunch of other HTTP clients.
Yeah, I like that decision.
Yeah, so for example, Hackney does the same thing. More popular libraries like curl, for example, I think also use the Mozilla store. So that's a pretty common thing to do.
Yeah, and so we are actually using the library that contains this certificate store, so you can very easily replace it yourself. So Mint still remains low level enough that you can switch CS store if you want, but we have a library whose only job is holding to this certificate store, basically, and it's the Mozilla certificate store. And that's its only job. And by default, that's what the Mint uses if you don't provide explicitly a certificate store.
One of the things you guys mentioned that I thought was interesting is talking about how you're not using processes, and you speak of that as a feature. And I know that that's not the case with other like HTTP Poison or something like that, other libraries. I'm just curious as to if you could give a little bit more insight and details to why you chose that route and what problem you were trying to avoid or solve.
Yeah, so the problem with so there's not really a problem with using processes. The thing that we were trying to solve and the shortcomings that we were trying to fix in other clients is that all other clients, at least that I know of, use processes, and that means that they impose a process architecture on your application. So usually there is one connection per process. That's kind of the standard way of doing it. One HTTP connection per process. And that means that every request, where it means that you're sending data and receiving data from to and from a server, needs to go through another process, right? It needs to go through this connection process. And you know that in Elixir, sending data to another process is either by copying it or by, like, if it's big binaries, they end up in a shared binary pool, space of memory. But if they're small, they get copied through processes. But in both cases, there's a little bit of overhead when sending data between processes, right? So if you so if an HTTP client imposes you a process architecture, it forces you to deal with that kind of stuff, to deal with that overhead, for example. It forces you to, maybe, for example, you have a process in your application that wants to use an HTTP client, but then it needs to have an HTTP client that lives in another process. So there needs to be inter-process communication in order to do requests where you might not need it, right? So the idea with Mint was to build something that you can use similarly as like in the same way as you use socket, TCP or SSL socket in Erlang, so that there's a process that owns this socket and it gets messages directly from the TCP or SSL driver. That was the idea. So, and then you can build your process architecture around this in the same way you do as you do with the TCP and SSL sockets, right? So, for example, with Mint, you can have one process that holds multiple connections, right? That's a really common use case. Like, you can do some kind of pooling in the same process, which can be a good idea because usually HTTP requests are IO bound. They're not CPU bound. So it's like, it can be fine to have multiple connections living in one process because that process is still mostly gonna wait for stuff to go to the server and come back from the server, right? So it can make sense. Another thing that's really, really useful is that with HTTP clients that impose a process architecture, you have no control over what process that would be, right? So in Mint, the nice thing is that you can put the connection inside any process, so any gen behavior that we have in Elixir and Erlang, right? So if you have a gen, you can use a gen server around the connection, and that's kind of the standard way of doing it, but you can use different things as well. And one of the ones that we like to talk about the most, I think, is gen stage. So you can use a connection directly, for example, in a gen stage producer or consumer, right? So that gives you, like, having no process gives you the flexibility to do those kinds of things. Whereas having a process architecture in the client means that you have to adapt to that. So this is just stepping to a lower level than most HTTP clients. That's really the goal that we had. So most HTTP client they do the socket handling and the HTTP protocol handling in the same in one process, in the same place, right? With Mint, we kind of separated that, and we built a wrapper around the sockets that can deal with HTTP, with the protocol, but then you need to deal with the connection, right? So you need to deal with, like, starting the connection, checking if it's live, closing the connection if necessary, and so that's your responsibility. So it's just a lower level client, and so that's.
So one question I had, I was imagining myself using this lower level library, and I know that HTTP2, and HTTP 1.1 as well, also have ability to do kind of multiple requests sort of at the same time, right? And so as I'm imagining, maybe I've queued up 5 requests. Or maybe one of my requests is sending server sent events or something like that, right? There can be all these different interleavings of maybe I'm getting back a response from this request. Is that tricky to deal with? In other words, if I'm going to be using Mint, and so I'm managing the process, I've opened the connection, and then I get some TCP message back, and how do I tie the response little data structures that come back from Mint? How do I tie those to my different requests?
So each request has when you open a request to the server, it gives you back a reference. It's like a unique term that ties the request to the response that you'll get. And Mint itself is streaming, so usually a good strategy is to just when you have multiple requests open, you can expect messages back from Mint that are from for any of those requests, right? So it's usually a good strategy to just keep, for example, an example is a map of requests of a request reference to response data. So it's like the headers or the part of the body. And when you get a response from Mint, you just find the corresponding response in the map by using the request reference. If that answers your question.
Yeah, no, that's super helpful. And that'll be, like you said before, I think that goes along with your priority to say it's up to the client. The client might have a lot of different things. Maybe you put those references into an ETS table and stream the data back into that ETS table about what's coming back, or maybe just a map instead of a gen server. You're leaving it up to the user to decide how to track requests and how to tie the responses back. But that makes sense. Every time I initiate a request, I get a reference, and all of the chunks of data that come back will have that same reference on them. Is that right?
Yes, exactly.
Yeah. And that kind of ties into one of the goals with the library. So the goal was to not necessarily provide every conceivable feature, but the library shouldn't limit you in doing something in kind of building that feature yourself. So that's one example. So with HTTP2, the library shouldn't limit you in doing multiplex requests if you want to. And for example, if you use HTTP1 connections, it shouldn't limit you in doing pipelining. So it's up to you if you want to pipeline the requests or not. And another example of this is that we for example, we don't support WebSockets, but the library doesn't prohibit you from implementing WebSockets on top of Mint. So as long as you have a library that knows how to encode and decode WebSocket frames, you could send those and you can receive those frame on a normal HTTP connection.
That's really cool. So I was wanting to ask, who do you think of when you think of like the ideal library that it sits on top of Mint? What are like your ideals? And I know that's a hard question, but what are you hoping people use this to build?
I think that's a really, really hard question. But we discussed this a little bit, and so right now I don't think we have So we have a little bit of a plan on how to provide higher level functionality on top of Mint. But really, so the goal of Mint was to be able to do that, right? To provide, since HTTP is such a commonly used thing, we really wanted to provide a tool that is low level enough that people can really just drop down to that if they need it, right? So. As for the plan that we have, so I'll answer to a question that's kind of similar to what you asked, but the plan that we have to get like higher level features on top of Mint, right now we discussed this last week with Pete Gamache, which is the author of a library called Mojito, which is a pool, HTTP pool based on top of Mint. So there's Mojito, and then we've been working on a pool as well that's right now it's called After 8. It's just all like a play of words on top of Mint, but right now the library is called After 8, and the idea is that we're so we discussed this with Eric and Pete as well, and the idea is that the plans for the future are that After Eight is going to provide a very low-level single-host pool on top of Mint. So it will do what we just discussed, where it will just wrap Mint around inside a process. So it will provide a simple process where that holds either one connection for HTTP2 or multiple connections for HTTP1. We haven't decided the architecture in the specifics yet, but that's the idea of having a process around the connection for a single host, because that's the way Mint works, right? A connection can only be to one host. So we'll just build a process wrapper around that. And that will be generic enough, hopefully, to build more complex pools on top of that, because more complex pools will be able to use the single host pools in a flexible way, so that they can build higher level functionality. And that's what Pete is going to do in Mojito. Is going to build. So what Mojito is now is a very high level pooling library that's very, very general purpose, similarly to what Hackney does or to what HTTP Poison does. So it's just so his goal with Mojito is that it just works. You just drop it down like what you do with Hackney today. You just drop it in your application and it works. And this After Eight library will be kind of a way in between Mint, which is very, very low level, and Mojito, sorry, which is very high level. Then there's what
mid level.
Yeah, kind of mid level. That's where it sits, so that people can be able to do stuff on top of that. And as far as interesting thing that I really want to explore with this, with the possibilities that Mint opens up are all based on all around pools, I would say. And one pool that me and Eric discussed is a registry-based pool for to have multi-host pooling. And the idea would be that you still base this on top of the single host pool in this After Eight library, but you route to the different pools by using registry. So
that's host. That's awesome.
Yeah, exactly. So each host will have its each host will be registered with a bunch of processes in the registry, and then you can figure out which connects which single host pool to talk to based on the host in the central registry. And that doesn't really add overhead because it's just an ETS lookup, so it's not limited by the process. You don't have to ask any process. You can read this from the ETS.
A library that does that was actually my answer to that question.
Yeah, that's definitely one option we can explore, and there's a chance that Pete might do that in Mojito. So he's been thinking about exploring that, and he might explore that solution in Mojito itself. So that's really, really interesting. Personally, sorry, go ahead.
I was just going to say that's the sort of thing that I think is low hanging fruit to really just get the power of the Beam more fleshed out in that space.
Yeah, definitely. And another one that I'm personally going to say it really, really excites me is a GenStage based pool for when you have to do usually when you have to do a lot of HTTP requests compressed together, like a lot of HTTP requests in a short amount of time. I really like the idea of using GenStage because you can use the Mint. Usually, so what I'm interested in is a pool based on GenStage for when you have to process a bunch of events, and each event ends up being processed by doing an HTTP request. So you can have a bunch of consumers, and each of those consumers can have an HTTP, a Mint connection right in the consumer in the process. And then you can generate a bunch of requests as a producer, and then feed them to this bunch of consumers that hold connections. And then that's really, really nice because GenStage takes care of the back pressure, and it automatically kind of decides which is the best connection to send requests to, because it's the one that's processing requests faster. That's just how GenStage works, right? It gives events to the consumer that's ready. So I think we would get a lot of nice behaviors by leveraging GenStage. But that's a very, very, I think it's too specific of a use case to be a general library. But I think it would be really nice to that someone builds this and writes a blog post about it. Let's just say that would be nice, because you would get the idea of how this works for a specific use case, and then people can adapt to that use case. But I think it would be really nice.
Yeah, I've actually had an application that worked like that, right? Where I had a GenStage pipeline of all these requests, and each consumer, its job was to make an HTTP request to an external service. And it's like, that is exactly what I was having to do. And Mint really would have fit well with that, partly because of what you were explaining there is the pool of connections is only ever the size of the number of consumers I have. And so I automatically have pool management. So I think it's great.
Yeah, exactly. Oh, sorry. Just to say that GenStage Pro also provides a lot of nice features for consuming, right? So, for example, if one of the connections disconnects, you can just not have the consumer process more requests, right? So you get really like a lot of benefits for free just based on like using GenStage in the right way, I would say, right?
Yeah, I think this is super exciting, actually. This is reminding me once I worked at a company where we provided webhooks about things that could happen in our platform back to the clients of the platform. And at the time, I remember, I'll drop a link here to an article. I remember reading this article from segment.com. They're talking about needing to deliver, billions of small events over HTTP per day. And there's all these interesting corner cases that come up. So like you can imagine if you have one customer that is expecting a lot of events to be delivered and they slowed down. And that one customer, because there's such a high volume of total requests, if you are just taking all requests and putting them into one big pool of the people that you might need to deliver to, it can fill up your whole pool, and your entire pool of workers can now just be waiting to try to deliver one event each to that same one customer. And their servers are down, and it's just not going to happen. And they go through all these different architectures that you can use to try to solve it. But if you started by just saying, delivering things is IO bound, let's just make one process per customer, and GenStage, you can do something like a partition based on the host that you're delivering to, then you'll still deliver them as fast as their server can accept the requests. And no one else would be impacted by the fact that they slow down. They just won't demand as much work. And so I think this is really fascinating. It's been years that I've been hearing about GenStage and the idea of demand-driven pipelines, but it didn't occur to me until this conversation how this takes this enormous problem of load balancing across a bunch of HTTP clients, and it just makes it really simple.
Just turns it into a supervision tree structure, just about.
Yep.
And it's kind of the same thing. So we were talking about the single host pools before, and you kind of, so if you partition so that you have a single process per customer, if you have a bug or that customer becomes overloaded and the process becomes it crashes for some reason, you only crash for the customer, and it's the same thing with the single host pools. So most HTTP libraries that do pooling, they have like a single process for the whole pool that manages everything, and that means if that pool process crashes, you bring down every HTTP connection that you have in your application. But if the single host pool goes down, you only bring down the connection for that specific customer or that specific host.
Yeah, and again, you might even, like, maybe that one customer, there's one process for that customer, and even if they have two hosts, maybe you deliver one copy of the event to their staging environment and one to production, or I don't know what, but you could have that, and you could still choose, do I want to actually have each of those be a separate process that each do their own requests, or I could choose to put them together if, maybe there's a business reason that I force myself to only deliver them in a certain order or something like that. And so I might choose to manage both those connections in one process. And Mint gives you that flexibility. You get to choose exactly how you want to do this. And to Andrea's point earlier, it's going to be a very common use case that you just want one connection per host, and somebody can write a general purpose pool that does that one thing. But then if you have more specific use cases, or if you know that GenStage is already going to partition all of your requests by the host they're heading to, then you don't need a separate pool that does per host. You could just open your own connection because you know you're only dealing with one host.
One of the things I think is worth talking about is Mint, this library. So you back in February, you announced on the Elixir blog that this library was being released. And in there, you talked about the current state of the library and how it was decided not to be part of the core Elixir libraries or runtime. I was just kind of wondering if you could give us an update on where things are and kind of how you see that fitting.
Yeah, so we started working on Mint about a year and a half ago, I would say, or maybe slightly less. And at that point, so it was me who started working on it. And the main reason why I started working on it was that we, at least at the time, had a lot of pain points when using the built-in HTTP client, the one called HTTPC. So we were using that for the Hex client, so Hex, the package manager. So it's the client that we use to download packages, download the package registry, and so on. And HTTPC it's a good HTTP client, but I would say that it doesn't get as much love as it maybe deserves. So the OTP team, they work on a bunch of different things, and the HTTP client that ships with OTP, it doesn't really get much work done. So it has a few bugs or issues, maybe I would call them, that we have to work around in Hex. And we can't really use other HTTP client libraries because of the way Hex integrates with Mix and the way it's delivered to the users. We can't have any dependencies. We can't have any dependencies in Hex. So I started working on an HTTP client that would be easy to vendor into Hex. So basically build a library that instead of being used as a dependency, we just copy the code into Hex. And a big pain point of doing vendoring is namespacing. And namespacing of modules is pretty easy. You can just have some kind of script that renames the modules. But the problem is when you start having things like name processes, shared ETS tables, and so on, because then it kind of becomes a lot more complicated. So that's kind of so at least for me, that was the reason why I wanted to build an HTTP client that didn't use any processes or any shared state. And at the same time, there were discussions, only informal discussions, as far as I know, about removing the HTTPC client from the Erlang OTP distribution. So if that was the case, we also needed a client for the Elixir standard library, because Mix, for example, does things like it downloads Rebar for you, it downloads Hex, for example. So we needed something to replace HTTPC. So that was the other reason. And then it turned out that it seems unlikely that HTTPC will be removed from OTP. So that was the only reason where we considered adding Mint to the standard library. And that's kind of the thinking that we have when we add things, or when we discuss adding things to the standard library. It's usually, if it's something that the standard library needs itself, or like Elixir needs it for Elixir to work, then we add this kind of library to the standard library, or we add this kind of functionality to the standard library. But unless that's not needed, then it could just as well be a separate library. So that's kind of the background on why we started to work on Mint and why it in the end weren't included in the standard library. And for your other question, I think was what's the current state of Mint? So another discussion was if we were going to do like a separate part of Mint would be we were discussing having two parts of Mint. So one would be the low level API that we have today, and the other would be a higher level API that would include process pooling and so on. But in the end, we also decided that would work better in separate libraries because there's so many, as we've talked about, there's so many different ways of doing pooling. It probably fits better to have that as separate libraries that can kind of do their own versions for their own use cases.
So what changed since when we released it? It's really like small things. So we released when Eric announced this on the Elixir blog, it was 0.1. Then we released. So since then, we've only released a bunch of small things like HTTP server pushes, support for that, a bunch of really like small stuff, and improvements on like error handling. Usually that's where improvements go in these kinds of protocols. And we're about to release 0.3 now, which contains functions to deal with passive sockets. So where you don't want to get messages from the socket directly to your process, but you actually want to read data out of the TCP socket through something like receive. So the TCP and SSL modules in Erlang provide a function called receive, spelled RECV usually, and that reads data synchronously out of the socket. So we provided a way to work with Mint with the socket being in passive mode. So you can now read from the socket with Mint.receive as well in the same way. And we added the ability to move the connection between processes. So in the TCP and SSL modules, when you have a socket, you have also a controlling process of that socket, which is a process that receives the messages from the socket, basically that owns the socket. And it's the process that starts the socket. And in Mint, you were forced to leave it like that. So the process that starts the connection will always be the owner of the socket. So now we have the functionality to move, to change the controlling process in a similar way as SSL and TCP do in Erlang. So it's all small stuff. So there weren't any big changes in the Mint side. And the Mint, as far as the Mint development goes, I think we're in a very good spot with Mint itself, because the APIs, I think we ended up with a good API that's provides everything that's needed to build on top of it. So I think Mint itself is in a very good place right now. It was like a bunch of refinements. It's still missing some very, very small things, like handling of priority frames in HTTP2, for example. But it's all like small things. So I think at least for me, the development effort right now that will move towards pooling mostly, just to get something out of pooling as well.
Yeah, so I would say that I would be very happy to release the current state of the library as 1.0 as the first stable version. And kind of, at least for me, the only thing I'm holding off on a bit is to see if the pooling efforts are running into any complications that might need changing of the public interface.
Yeah, exactly. I would be happy with 1.0 as well, but waiting for that makes a lot of sense. Waiting to see if pools are able to be built on top of the current state of Mint, but feature-wise and API-wise, I think we're really happy with what we have now.
So it sounds like there's going to be a 0.3 release. Wait, let it bake for a little bit, let the community make use of it, wait to see if there's any feedback, and then, I don't know, maybe a few months later or something like that, maybe we might see a 1.0 release. Does that sound right?
Yeah, something like that, yeah.
I would bet if you want to sell it like at a keynote for Apple or something, I would say by the end of the year you'll have 1.0. But it's not going to meet Mint whatsoever. So like if we just want to say it by end of year, it sounds like a good estimate, but I don't really know. Could be earlier, could be later.
The listeners can't see, but Andrea just put on a black turtleneck and did his Steve Jobs impression.
Oh, one more thing. Yeah. So I did have a question. You're talking about building an HTTP library. I'm just curious, was dealing with an HTTP protocol a new thing for both of you or one of you? Like, was this like, like you mentioned having to worry about priority frames with HTTP protocol too. So I'm just like, what was that like building this kind of a library? You know, I assume you're like having to read specs and, what was that like?
So I've been looking into HTTP in different ways since I started working on Hex, because like when you build that kind of client, there's so many things you need to learn and understand. For example, in the beginning, we used pipelining for performance, but it turns out that that's not very well supported. You need to kind of understand different ways of doing proxying and like fixing bugs in the HTTP library, or at least look into the different issues that we ran into. Kind of forced me to learn a lot about the HTTP 1 protocol. And Andrea, he's already written an HTTP 2 client, so that kind of worked out well.
Yeah, so I had worked on HTTP 2, the protocol, because we at a couple of companies ago, because we wanted to send notifications to Apple devices through APNS, and they moved to HTTP 2 now. So we needed something quick and dirty when I worked on this. So I built like a very simple HTTP2 client that really only worked with the subset of HTTP2 that APNS was using. So I had a little bit of experience with that. But HTTP2 itself was really, really challenging, because HTTP1 has a bunch of utilities in Erlang that we can use, like for parsing, for example. There's a bunch of stuff that we can already take advantage of. And as a protocol, I think it's a little bit simpler. It's a little bit more streamlined, and it's a little bit easier to deal with. Like, for example, requests that don't have IDs, right? It's just like a queue of requests going in and out. So it's there are some things that are a little bit easier to deal with. HTTP2 was a challenge for me, honestly, because it's a complex protocol. There's a lot of stuff going on. There's really a lot of state handling in the connection. Like the PR has to do a lot of do a lot of bookkeeping to keep the protocol happy. And there's a bunch of things like headers. They have their own protocol, which is HPAC. So you have to encode headers through a protocol. So we had to add that as well. And since when we were starting this, we started with this with the idea of including in core. I had to write the code for the protocol as well, because then we wanted to not have dependencies on this, right? So it ended up being a bunch of work. And yeah, so yeah, that was the story. HTTP2 was a pain in the ass, if I can say that.
And another problem that we had was that since the goal from the beginning always was to support both HTTP1 and HTTP2, and we wanted a unified API for them, which turned out to be a bit complicated because, well, in the end, I guess it was easier than we thought. But before we kind of found that API, it was a bit hard to reconciliating the different behaviors, I would say. So, for example, the request reference that we have isn't really necessary for HTTP1 because all the requests just so if you don't use pipelining, you can only have one request at a time, and if you use pipelining, it's just a queue of requests. And things like vocabulary or naming things can be difficult as well, because HTTP2 talk a lot about streams and frames and so on, but that doesn't exist in HTTP1. So we decided to use the HTTP1 vocabulary with requests and responses and so on, which means that if you want to use Mint specifically for HTTP2, you kind of have to, I mean, it's kind of straightforward, but in some places you have to kind of understand the naming of things, and that the request is just a stream and so on. So that was kind of, I at least for me, I work mostly on the HTTP1 part. For me, that was harder than like reading the specifications and looking at the protocols and so on.
Yeah, but for what it's worth, I think we ended up, like, in the end, like, it took a long time to end up with this API, I think, but we ended up with an API that I think works. I'm really, really, really happy with. I think it works really well. And as for what it's worth, like in HTTP2, it's documented whenever like the mapping to HTTP2 concepts is usually documented, like in the request function. It says, like, this in HTTP2, this means opening the stream, right? Because like maybe people will care, but they usually, like, the mapping itself is in the documentation, even if it's not in the names of the concepts we talk about with the naming of the functions in the documentation.
One question I think is always helpful and kind of framing where this fits in terms of me as a developer. I'm a user of this library. Where would you say Mint is not a good idea to try and apply?
So if you're just, so that's a hard question to answer, because for me, as long as you're doing HTTP, Mint fits somewhere in the stack for me. And that was always the idea. But I don't think it makes sense to always use Mint directly, and that's kind of why we're working on these different pooling libraries and so on. But if there is a case where you want to use HTTP and Mint doesn't work for you, I would say that will be a failure of the library. But like if you're used to using Hackney, if you're used to using HTTP-C, the Mint API is going to be annoying to use. And in the beginning, it's going to be hard to use correctly as well, because you need to do things like maintaining you don't maintain the connection state, but you need to make sure that it's stored somewhere in your process. Since there is no separate shared state that handles that connection, you need to handle that connection, and you need to make sure that you don't somewhere, for example, when you make a request and you don't store the resulting if you make a request and you don't store the state of the connection between the calls, you're going to have a very weird bug, because essentially the connection state is going to be corrupted. And it's going to look like a bug in the library, because the library expects some state of the connection, but the state of the connection is actually different. Those kind of things can be hard to find. And all this like streaming API where you get parts of the response, there's no like single function, request function, where I give you this URL and you give me a request body and I get a request body back as a single function call. That doesn't exist. So the APIs in other libraries that you might have used before is definitely going to be easier to use.
I think to add to what Eric said, I think he nailed it when he said that Mint, I see as well Mint being part of the HTTP stack at some level. So there's no, I think, HTTP use case where Mint is a bad idea, I think, at some level. But for now, like using Mint, I think that using Mint directly, if you need a simple high-level API, is a bad idea. Like you're going to have to deal with more trouble than it's worth for, like if you don't have a specific use case where you want to do something weird with library, like use it in a lower level way. But the idea is that hopefully soon enough we will have libraries on top of Mint, like the ones that I talked about at the beginning, where we have a single spool or Mojito that would be like a very high level interface, and then so that will cover the use case, for example, of having to do like simple like HTTP requests, right? And it will still be based on top of Mint. So right now, I would say that to rephrase the question to what do you think is a good idea? Where do you think is a good idea to use Mint? I would say that right now, it's nice to use Mint directly in a low-level use case or use case where you need a lot of control. But hopefully, in the near future, you'll be able to leverage Mint indirectly by using something that's on top of it. So yeah.
Awesome. I know benchmarks are always kind of a sore point just because what do they really measure? But I had seen some benchmarks where people were using Mint compared to some other solutions. And what I took away mostly from it was, well, it was significantly faster. But what I took away mostly is that because it is that lower level library where you choose the right architecture for the problem that you have in your project, you can basically kind of tune your usage of it. And so the benchmark for that case will be better for your application than some other library that wasn't tuned and designed for your need. So, but I just think that's something worth keeping in mind whenever people look at micro benchmarks. It's how much value can you really get out of them? But like it is worth, even just with your own application, kind of saying, well, if we use Hackney or HTTP Poison or some other library, and if we do it with Mint, and then you could even benchmark different architectures of how you're arranging your usage of the Mint library. Oh, are we going to use it with a pool or GenStage or whatever? I think that's helps inform our decisions as designers of systems as to what is the best case and the best application of technology for our problems.
For what it's worth, I had no idea about benchmarks using Mint, and I'm really, really happy that it's fast, because I definitely did not do a single thing while working on Mint that geared towards it being fast. I kind of always wrote code in Mint saying, I guess it's going to be faster because it's not using process, or I guess it's going to be fine, but I wanted it to work correctly, right? I really never looked at benchmarks, never did any benchmarking myself. So I'm super, super happy that it's fast. I always waited, people would find out, and if it's slower, I'll just play the correctness card. I'll say, yeah, but it's correct, right? So it's a really, really good thing that it's even fast.
Nice. Well, is there anything else you'd like to cover or mention before we go on to picks?
I don't think I have anything.
All right. Well, that was a really great conversation, and I encourage people to check out the library. We will include links to the articles. There's multiple sources that you can look at and to kind of get your feet wet with understanding Mint. I would encourage people to check those out. But I guess from there, then let's go on to picks. Michael, do you have one that you can share?
Yeah, two quick ones this week for me. So first one, I'll drop a link to this video. Matt Nowak from Discord gave a talk at Codebeam SF not too long ago. They were dealing with some issues where they would have tens of thousands of processes all linked to one other process. This is using Erlang distribution. And if it crashed, it would create a thundering herd problem, because now you have a whole bunch of processes throughout your distributed set of Erlang nodes that all want to reconnect or rediscover this thing right away. And so they created a library called ZenMonitor, which lets you monitor or link to processes, but you kind of are linking to actually an intermediary, and they will control kind of how quickly they notify everyone else about this process going down. So it's an interesting use case around, let's follow the Erlang principles, but we need to tune it for our use case because something interesting is happening in our system. So I always really love those kinds of deep dive talks. I thought that one was really great. The other one is totally non-technical. So a friend sent me a link, another YouTube link that I'll drop here. There's this French person who has this amazing YouTube channel. He's kind of half baker and half engineer, but with a hilarious accent and personality the entire time. And he's trying to make the perfect croissant. And this video is about him trying to build a machine that includes 3D printed parts and milling and all sorts of things, so that he has a machine to reliably fold out the dough to just the right layer heights that he wants for his pastry. And I just had so much fun watching this video. It really, it speaks to both my love of food and my love of engineering at the same time. So I thought that one was worth sharing.
Awesome. Josh, do you have something?
Well, I sure was talking, so sorry about that. Yeah, so I have a few picks. My first pick is meat. Meat is good. You should eat meat. My second pick is related to that. Yesterday, I had a sous vide steak, I think for the second time, but we sous vide a steak, and we then hit it with a blowtorch to actually sear it, and that was outstanding. So it's an experience you should try it. There's actually a link to some sous vide options if you're interested. But my real pick is this really cool article and then Twitter thread where this guy that I follow that just does cool digital art produces these depth of field images from 3D point clouds. And he was able to sort of like refine this technique. And then he got a bunch of open source point clouds for interesting architectural subjects and applied art to them via computers. And it's really, really just interesting. I enjoy looking at the pictures.
Cool. All right. Mine is just recently the Elixir Phoenix book. It's currently in beta. It had a new release, and they said this is the last of the beta release. So if you haven't already picked up a copy, I think it's a great book. It's a great resource, especially because it's been updated as new community kind of patterns have been evolving in terms of contexts and naming. And now with the new Elixir 1.9 releases, like they go back and they've updated the docs on really how the config should look with releases. And so in this latest release, they added chapter 14, the what's next. And in there, they kind of give a treatment to live view. They talk about PubSub 2.0 and adding telemetry information to Phoenix and other coming things. So I just wanted to let people know that resource is there. It's been updated, and check it out if you haven't already. All right, Eric, do you have something to share?
Yeah, so first I want to share a tool, or I guess an application called InkDrop. So it's a simple note-taking application. I've been using a bunch of different note applications over the years, but I usually feel that they are way too bloated and they have way too many features for what I need. So InkDrop is really nice because all I really need is an application where I can write some notes and they are stored somewhere in the cloud, and I can use the application on my laptop and my phone, and that's really all that I need. So InkDrop is perfect for me. And since you mentioned the Programming Phoenix book, I guess it won't be too shameful of me to plug my own book called Programming Ecto, written by me and Darren Wilson, also by the Pragmatic Bookshelf. So yeah, I would recommend that. The Ecto docs are great, but the book goes into a bit more depth and has some common use cases and problems that you can run into, and the solutions for them, of course. So yeah, that's my picks.
Awesome. And Andrea, do you have something to share?
I do. So the first thing is something we talked about, but the two libraries, pooling libraries that we talked about, I think it's nice to share the links to those. So After 8 and Mojito, if you're interested. And then one more thing that I want to share is an app that I bought a few months ago that I really, really use a lot, and it's called Shush. And it's basically an app that lets you set a hotkey to mute your microphone, both in like mute unmute toggling, as well as like push to talk, right? So I'm using it right now, like I'm holding the two keys on my keyboard down in order to get audio to you. And if I lift my fingers, it will mute. And then if I tap it twice, it will actually switch to the opposite, like push to mute, right? So it's really nice, and especially for people that work from home, I think it's where you're doing a lot of meetings with your computer, like a lot of remote meetings. It's really nice to be able to, especially with a lot of people, to be able to do that with an alt key where you can move around your computer. But then when you need to say something, just push the talk. And same goes for like when you're in a meeting and you want to push the silence, because like you're coughing, for example, or something like that, and you want to push the silence. I think it's a really, really nice app. It costs like $5, I think, but it's worth more to me at least.
Yeah, I use it and it's great.
Awesome. Well, thank you guys for coming on. It's been a pleasure talking with you. If people would like to follow you or get in touch with you, or how would you direct them to do that?
So easiest is to find me on Twitter, EMJII on Twitter. So if you want to talk to me, you should reach out to me there.
Yeah, same here. What You Hide on Twitter, which is a weird name, but that's what it is. And it's the same on GitHub as well. And on Instagram, if you want to follow me on Instagram.
Big thank you to both of you also for your work on this library. You talked about, especially Andre, you talked about building out the HTTP2 protocol and a lot of trickiness there. And I'm so glad that as a community member, I won't have to ever worry about the protocol part of it. I might need to worry about lots of other HTTP things, but many thanks for your hard work on this and for all the other community projects around Elixir that you guys have done. Thanks.
Hear, hear.
Thank you.
Yes, you guys are prolific in your involvement, and we appreciate it. There are other topics that we would love to invite you both back on individually to talk further about. So we hope to be hearing from you guys again in the future. All right, but that is it for today. We hope you'll join us next week on Elixir Mix.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your